Okay, we're in Chapter 5. Now, the bad thing about Chapter 5 is it's similar to Chapter 1. In Chapter 1, we did something different in every section, and the same thing happens in Chapter 5. It doesn't necessarily build upon itself. It just continues doing things that are relatively weird. So on page 327, we have tanks that are filling and tanks that are emptying, and we have circuits that are doing things on page 332, and we have other things going on. And then we have problems to solve. And what we're going to do is we're going to solve problems that are systems of linear differential equations somehow. All right. So in this case, we're going to solve problems 11 through 19. So I'll start with number 12. And okay, so number 12, and we're in section 5.1, says x prime is y, and y prime is x. Is that what it says? Yeah, x prime is y and y prime is x. All right, well, what are we going to do about that? Well, if we take the first guy and we say that y prime is x double prime, then we can rewrite the equation as x double prime minus x is equal to 0. So we can take the derivative of the y guy and get that. Now that I have that x double prime minus x is equal to 0, I can say, well, gee, that has a characteristic equation. And that characteristic equation is m squared minus 1 is 0. So m squared is equal to 1. M is equal to plus or minus 1. So x of t is going to be c1 e to the, well, if I'm, yeah, I guess so, c1 e to the minus t plus c2 e to the t. And if that's the case, then y has to be x prime, so y of t has to be x prime of t, which would be c2 e to the t minus c1 e to the minus t. And now I'm done. If I could spell done. I still can't spell done. Maybe I can spell done now. Done. And then we could check our work, and is the second derivative of x, is it the other guy, and is it in fact what it's supposed to be? And yep, I guess so. I see. So was that easy enough? All right. Not that you would have known to do that, would you? No, you may not have known to do that, but we are in this chapter, so that's what we're doing. That was 12? 14. So x prime is 10x. X prime is 10y. See if I can write the problem down. And y prime is minus 10x. In x0 is equal to something, and y0 is equal to something, which means now we can solve for initial conditions 3 and 4. Okay, so we go and say, well, from this equation I know that y is equal to 1 over 10 x prime. And I know that y prime is going to be 1 over 10 x double prime. which I also know is equal to minus 10x. So I'd have x double prime plus 100x is equal to 0. I'd have a characteristic equation that says m squared plus 100 equals 0. M is equal to plus or minus 10i. So x of t would be c1 cosine 10t plus c2 sine 10t. I'd apply an initial condition x at 0 is 3, implying that c1 is 3. So now I know x of t is equal to 3 cosine 10t plus c2 sine 10t. And then I'd come back and say that x prime is 10y. Alright, so 10y at t is equal to x prime at t, which will be minus 30 sine 10t plus 10 c2 cosine 10t. Y of t would equal to minus 3 sine plus c2 cosine, and y at 0, applying the initial condition, has to be 4, implying that c2 is 4. So now I've got y of t is equal to minus 3 sine 10t plus 4 cosine 10t, and x of t is equal to 3 cosine 10t plus 4 sine 10t. Is it? Is that what it is? X of t, 3 cosine, yes. Alright. And then I would check my work. And so checking is x of 0, 3. Check. Is y of 0, 4. Check. Alright, so both of my initial conditions check. And x prime is supposed to be 10y. Okay, so x prime is minus 30 sine 10t plus 40 cosine 10t, which is in fact 10y. Check. And then I would check that y prime is minus 10x. So y prime, there's y. Y prime is minus 30 cosine 10 minus 40 sine 10t, and that's supposed to equal minus 10x, and it does. Check. So not only did I do it, but I also checked my work. Number 14, we did 14. Number 16. Yeah, odd one, so okay, got to do 16. You have to do 16, I don't. I can do 16, you can do 17. X prime is 8y. X prime is 8y, and y prime is minus 2x. No initial conditions, so we don't have to solve for them, but it would be nice if our equation signs looked like equation signs. Okay, so I'm going to write it as y is equal to 1/8 x prime, and then y prime would be 1/8 x double prime. I'd substitute that up into there and say that 1/8 x double prime plus 2x is equal to 0. I have a characteristic equation. 1/8 m squared plus 2 is a 0. M is going to be plus or minus 4i, and x of t c1 cosine 4x plus c2 sine 4x. Oh no, bad variable, t and t. X is over there. And this is 16, so y should be 1/8 of x prime. So x prime would be 4 minus 4 c1 sine 4x plus 4 c2 cosine 4t, 4t as I was saying, and y prime, x prime is 8y, which is 8y. Therefore, oh, you like that? Y of t equals 1/2 c2. Why doesn't that look like a 1/2 to me? Didn't I say 1/2? I clearly said 1/2, right? Cosine 4. What's wrong with this pen? Minus 1/2 sine 4t. And so we're done with number 16, going on to 18. Okay, so x is equal to x prime is equal to minus y, and y prime is equal to 10x minus 7y, 10x minus 7y, and x at 0 is something, and y at 0 is something, I think. 2 and minus 7. But I didn't write the right, oh yeah, I wrote the right problem down. 2 minus 7. Okay. So, put the minus sign on the other side. Y prime is equal to minus x double prime. Which is equal to 10x plus 7x prime. Okay, so this is y prime. So there's 10x minus 7y, but y is equal to minus x prime, so that makes it plus 7x prime. So I got that x double prime plus 10x, oh, way to go, can't even spell today, plus 7x prime plus 10x is equal to 0. I now have a characteristic equation. M squared 7m plus 10 is equal to 0. That clearly factors m plus 5, m plus 2. X of t is equal to c1e to the minus 5t plus c2e to the minus 2t. And x at 0 is 2, which is going to be c1 plus c2. All right, now we come back and y is equal to minus x prime. Okay, so y of t is equal to minus x prime of t, which is going to be c5 c1e to the minus 5t plus 2c2e to the minus 2t, and y at 0 is minus 7, which is 5c1 plus 2c2. All right, so we have two equations, two unknowns. c1 plus c2 is 2, and 5c1 plus 2c2 is equal to minus 7. Well, okay, if we say so. So c1 is equal to, using whose rule? Kramer's rule, I remember. 1152 on the bottom, 2 minus 7, 1, 2 on the top. 4 plus 7 is 13, divided by 2 minus 5 minus 3, so minus 13 over 3. Alright, well, if C1's minus 13 over C, then C2 has to be 19 over 3. Okay, so 13 over 3 with a minus sign times 5.
Is it 4 plus 7 is 11?
Plus 7 and 4 is 11. Now, how did I get 13? All right. 11, all right, that's 11 minus 11 thirds, so 5 minus 11 thirds. Okay, so plus, this is 17. 17. I'm still checking my work now. All right, so 5 times 17 thirds. No. 5 times 11 thirds with a minus sign plus 2 times 17 thirds equals minus 7. Okay. Well, that must be the case. So x of t had best be c1 minus 11 over 3 e to the minus 5t plus c2 17 over 3 e to the minus 2t. And that would be final answer. And do we want to check our work? Nah, we'll just go on to the next. Oh, we'll just look in the back of the book. 15-1, which one is this? 18?
Yep.
15-1, 5-1, 18. That's 5-2, 5-1, 18. They have 17 over 3 and minus 11 over 3. Is that what we have?
Yeah.
Oh, okay. So they have the same thing that we do. But they also have a y of t answer. So we still have to come up with a y of t answer. Y of t equals minus the derivative of that guy. Okay, so it'd be minus the derivative of x prime. So that would be minus 55 over 3 e to the minus 5t plus what? Plus 34? 34 over 3 e to the minus 2t. All right. No, it's minus. So when I do it, when I take the derivative, everything, all the minuses turn minus all the time, but then I have to take minus of the minus, so everything goes back the way it was, yeah. All right, number 20. And then we're done with this section. I hope it's an easy one. X prime is equal to y, and y prime is equal to minus 9x plus 6y. Alright, so y prime is x double prime, which is going to be minus 9x plus 6x prime. So x double prime minus 6x prime plus 9x is equal to 0 as a characteristic equation of m squared minus 6m plus 9. So m is going to be equal to minus 3, right? Minus 3, minus 3. So I have a double root. And so x of t is equal to c1 e to the minus, or is it plus 3t? Oh, I'm second guessing myself now. Minus 3t. Plus c2x e to the minus 3t. That's what happens when you do chapter 4 and you're doing Laplace transforms. You get confused. Y is just x prime. So y of t is going to be minus 3c1 e to the minus 3t minus 3c2. Got ahead of myself there, didn't I? A little over exuberance. Plus c2e to the minus 3t minus 3c2x e to the minus 3t. And that's probably right. Moving on to section 5.2. I hope it's just as easy there. I mean, those are relatively okay. And okay, it looks like we're doing silly things here. Method of elimination. So we're going to try to eliminate something. Okay. Alright, and then we're going to do something weird on page 341. Okay, got that down. And then even weirder as we proceed on. Okay, so now the issue is we only look at section 5.2 to solve the problems that we have to solve. Otherwise, we will get bogged down in minutia. So we're going to start with problem number 2. We're doing every other one. And I've got, see what it says to do. Find the general solution of the linear systems in problems 1 through 4. If initials are given, find the particular solution. Okay. In problems 1 through 6, use a computer system or graphing computer to construct the direction field and the typical selection curves. Okay, well, we're not in the business of drawing curves, so we're not going to do that. All right, so no initial conditions. All we have to do is come up with the general solution. Okay, so x prime equals x minus 2y, and y prime equals 2x minus y, 2x minus 3y. Now, if in fact x prime is x minus 2y and y prime is 2x minus 3y, would it not be reasonable to assume that both of those guys have to have the same characteristic equation, x and y, in order for that to be the case? Would that not be a reasonable thing to think about? If x prime is the linear combination of two things, x and y prime is a linear combination of two things, y and x, then their characteristic equation has to be the same characteristic equation. Okay, so now that we've established that that's the case, now we have to decide, how do we get that characteristic equation? And that's what all this stuff in the front of the chapters are about here, telling you how to do that. And let's see, do I remember that or not? I don't remember. I don't remember if I remember it. Yeah. Okay. So that's what we're going to do. All right. Well, let's see. Yeah, I guess that's something we're going to do. We're going to do that later. I just know we are. I'm going to take this guy right here. I'm going to bring him down here. And I'm going to write that y is equal to minus 1/2 x prime plus 1/2 x. And then I'm going to ask myself, did I do that right? Yes, I did. Okay, and then I'm going to say y prime is minus 1/2 x double prime plus 1/2 x prime, which has to equal 3x minus 3 times y, which is minus 1/2 x prime plus 1/2 x. Isn't that lovely?
That'd be 2x.
What? Where?
When you have 3x minus 3 times that quantity. Is that?
Yeah, that should be a 2x. Yeah, good call. Okay, so I've got minus 1/2 x double prime. I've got 3 halves positive. Those 3 halves are going to be negative. I'm going to have minus x prime. I've got minus 3 halves plus 2, making it positive 1/2, making it minus 1/2 x equals 0. Okay. I choose to multiply everything through by minus 2. X double prime plus 2x prime plus x is equal to 0. I have a characteristic equation, and m is going to be equal to plus or minus the square root of, no, plus or minus 1i. What is that? Plus or minus I. Did I skip enough steps? Let's see, I got m squared plus 2m plus 1. That's m plus 1. The quantity squared has to be 0. So m is going to be minus 1 minus 1. 2 roots. Minus 1 minus 1. Good thing I went back and looked at all the skipping of steps there. So that being the case, x of t is going to be c1 e to the minus t plus c2x e to the minus t. Fine. Okay. Okay, so we'll come up with an x prime. X prime is minus c1 e to the minus t minus c2 e to the minus t, and that's going to equal x, which is c1 e to the minus t plus c2 e to the minus t minus 2y. Minus 2y. Okay, so y of t is equal to. Okay, so that goes on the other side of the equation. This comes on this side of the equation. They all add up. There's all 2's. I divide them all by 2's. c1 e to the minus t plus c2 e to the minus, oh, bummer. How much do I need to erase? All the way back to there. Alright, as I was saying, x prime of t is minus c1 e to the minus t plus c2 e to the minus t minus c2x e to the minus t. Okay, that's what I meant to say. I just didn't say it the first time. All right, now that I did that, well, I want to take the derivative. Okay, so I got the derivative of it. Okay, so the derivative of it has to equal x. c1 e to the minus t plus c2x e to the minus t minus 2y. Minus 2y. So y is going to be equal to, we'll put a 2 there so we'll not worry about it yet. Okay, so I got 2 c1 e to the minus t. I got plus 2 c2x e to the minus t, and then I got minus c2e to the minus t. So final answer, y of t, c1 e to the minus t plus c2x e to the minus t minus 1/2 c2e to the minus t. Okay, and we'll see if the grad student wanted to get it right. Number 2. Oh, yeah. I think I got it right. But I didn't. We all know that the variable is t, right? And so this is a t variable, not what I have. So there's a t there, a t there. C2 t e to the minus t. This is a t variable there and there. T. How did I miss that anyway? T. Okay. Excellent. Check by backup book. All right. We're skipping 4, going to number 6. Number 6. X prime is x9y. X prime, x plus 9y. Y prime minus 2 minus 5. Minus 2x minus 5y. And we have initial conditions. Y at 0, x at 0. X at 0 is 3. Y at 0 is 2. Okay. So I'm going to solve this equation and say y is equal to x prime 1/9 x prime minus 1/9 x, and then y prime 1/9 x prime double prime minus 1/9 x prime, which has to be minus 2x minus 5 times y. Okay, and y is going to be 1/9 x prime minus 1/9 x. Well, okay, so I got 1/9 x double prime minus 1/9 x, well, 1/9. Over here I have, what we'll do is we'll call it plus a minus 1/9. And over here I got 5/9, which are negative, which are going to be positive, plus 5/9 x prime. And then I've got 5/9, which are positive, and I have 18/9, which are negative, which will give me negative 13/9, which gives me positive 13/9 x is equal to 0. And I'm hoping that I did that right. I'm going to multiply everything through by 9 so I don't have to deal with a 9 anymore. X double prime plus 4x prime plus 13x is equal to 0. Now that doesn't factor, which causes me great discomfort. So we'll go see if we think we did something wrong. Well, I don't see that we did anything wrong, do you? Nope, I don't see that we did anything wrong. Okay, so characteristic equation, m squared plus 4m plus 13 equals 0. M is equal to, using the half quadratic formula, minus 2 plus or minus the square root of 2 squared minus 13. Now 4 minus 13 is 9, right? And the square root of 9 is 3. So I'm going to have minus 2 plus or minus 3i. Okay, well that's pretty good. So are we solving for x of t? Okay, x of t. X of t is equal to c1. No, it isn't. Yeah, it is. C1 e to the minus 2t cosine 3t plus C2 e to the minus 2t sine 3t. Okay. X at 0 is 3. X at 0 is 3, implying C1 is 3. Okay, so x of t, 3, e to the minus 2t cosine 3t plus c2 e to the minus 2t sine 3t. All right, back to the problem. We're doing 6. Are we doing 6? Yes, we're doing 6. So x prime is equal to minus 2. No, it isn't. Minus 6 e to the minus 2t minus 9 e to the minus 2t sine 3t minus 2 c2 e to the minus 2t sine 3t plus c plus 3 c2 e to the minus 2t cosine 3t. Oh, I'm just so happy that I did that. Now x prime is equal to x plus 9y is equal to, this is going to be equal to x 3 e to the minus 2t cosine 3t plus c2 e to the minus 2t sine 3t plus 9y. Okay, now all we have to do is solve for y. Now all we have to do is be able to see enough of the problem so we can solve for y. Okay, so 9y equals, okay, everything else goes on the other side of the equation. How can that be? And it can't be. There has to be a cosine 3t sitting right here. Cosine 3t. Okay, that's better now. I like that better. So I got cosine 3t, another cosine 3t. I have 3. 1, 2, 3 cosine 3t's, right? So I've got minus 9 plus 3c2 e to the minus 2t cosine 3t, and then I got plus the sine guys. Okay, I got 1, 2, 3 sine guys. So I got a minus 9, I got a minus 10, minus 10 minus 2c2 e to the minus 2t sine 3t. Oh, I hope I did that right. Then y is going to equal all these things divided by 9. Minus 9 plus 3c2 over 9 e to the minus 2t cosine 3t plus minus 10 minus 2c2 e to the minus 2t sine 3t. Apply our initial condition. Y at 0 is what? Y at 0 is 2. Okay, this term becomes 0. I've got minus 9 plus 3c2 divided by 9. It has to be 2. So I got 18. I got 27. 27 divided by 3 is 9. So C2 is 9. Okay, so C2 is 9. Y of t, final answer is 27, that'd be a 2. 2 e to the minus 2t cosine 3t minus 9, 18, 28. 28 e to the minus 2t sine 3t. Okay, that's cool. Is that cool?
Mm-hmm.
We haven't checked it with Maple yet. So we'll do a check with Maple on this one. What do you think? Think Maple can handle this?
Hope so.
Oh, I hope so too. Almost as much as I hope they come up with my answer. Yeah. Never can tell though. Alright, so tools, assistance, ordinary differential equation solver. Edit. Assist. Okay, so I want, this is number 6. So I want x with respect to t, and I want a first derivative, and I want x with respect to t, the 0th derivative, and then I want y with respect to t. Y with respect to t. Alright, so I got x with respect to t equals x plus 9y. X plus 9y. Add. Okay, so I get a 4-0. I'm putting in the first equation right? Yes, I think so. Assist. Okay, I want y, a first derivative. I want y, no derivative. And then I want x, no derivative with respect to t. Where did the x go? Alright. And I missed it. That's because I hit the wrong thing. Alright, so y equals, okay, minus 5 y minus 2x minus 2 times x. Add. Okay, it looks like we have our two equations in correctly. We spelled them right. Okay, fine. Now we're going to put in initial conditions, and we're going to say x at 0 is 3, and we're going to put y at 0 is, now why are we putting those guys in for? Oh, I know. Okay, so we got that. Solve symbolically. Boom. Solve. Dum, 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 dum. Is that what we have? No. We don't have that. Okay, x of t, 9 sine, 3 cosine. X of t. X of t. X of t. We never solved for x of t. But C2 is 9. So it would be 9 sine, 3 cosine. Is that what it said? 9 sine, 3 cosine. So we got x of t right. Now y of t is supposed to be 2 cosine minus 4 sine. Is that what we have? X of y of t. Y of t is supposed to be, oh, bummer. That's not what we have for y of t. Okay, so we got x of t right, but somehow getting the right constant, C2 is 9, we ended up getting the wrong number. Are we supposed to have a 2 in front of the cosine? No, we're supposed to have a 3 in front of the cosine. All right, so we'll work on the 3 in front of the cosine first. That's 18, right? 18 plus 9 is 27, divided by 3, making C2 9. Okay. But if C2 were 9, that would be 27. No, 9 times 3 is how much? No, that's right. I'd have a 2 there. Y at 0 is 2. Y at 0 is 2, yeah. So we have a 2 cosine. 2 cosine is exactly what we have. It's the minus 4 sine that we have wrong. Okay, so the 2 cosine is fine. Over here we want this to be 5. We want that to be a 4. Okay, so back to the sine guy. Here's minus 10. Oh, wait a minute. All right, there's minus 10. There's a minus 2C2. There's another C2. So I added this guy, I made him negative, and I took him away from the 10 when I shouldn't have. Okay, I got it. So this guy's wrong. Luckily, he is the last thing we had to do. So what should he be? Okay, so I got a sign there, a sign here, and a sign there. And minus 9 stays by itself. Here I've got minus 2, and this guy makes it minus 3. Minus 3C2. Minus C32 divided by 9. Minus 9 minus 3C2 divided by 9 makes that a minus 4. Minus 4. Well, Thank you, Maple, for allowing us to get that close. Let's see, do we have to go up to number 20?
There's 19 again, so
19, okay, so we don't have to do number 20, so we won't. And number 18, 1, 2, 3 equations. That looks like a real pain, doesn't it? That looks like something that can't be done on a smart board. I would have to see more than we have to do. Okay, so our choices are to declare section 5.2 over and move to section 5.3 next time. I think we should do that.
yes,
Yeah.
that sounds good.
And do as many of those problems as you think you should, giving yourself plenty of room on a piece of paper, making sure your answers are correct in the back of the book. Control, Shift.